shortcut number 1, the power rule. So a little review. You know the instantaneous rate of change is the slope of the tangent line at the curve at that point. So if you had any curve, you could take a point, draw a tangent line, and when we do the definition of the derivative at that point, we are finding the slope of that tangent line. The derivative is a function that lets us find any instantaneous rate of change at any point on the curve. And so far, we've just been doing that with the definition of the derivative. So here's our definition of the derivative. If you had x squared, you could do the limit as x plus h squared minus x squared all over h. Expand it out, simplify, evaluate your limit, and get that the derivative would be 2x. And so what mathematicians do is they start doing a bunch of things like with the definition that they have and start looking for a pattern. So we have our definition of the derivative for x squared. We're also going to do it for x cubed and for x to the power of 4. X cubed. So now the x plus h squared expanding is a little bit more involved, but you could do it fairly quickly. Remember how to use Pascal's triangle for expanding things? In this case, the 1, 3, 3, 1 shows up 1, 3, 3, 1 when expanding x plus h cubed. We start off with x cubed, then 1 less x, then 1 less x, then no x's. Start off with 0 h's, then 1 h, then 2 h's, then 3 h's. And the coefficients can come from Pascal's triangle. So again, simplify, factor out your h, evaluate your limit, and we get 3x squared. And finally, doing x to the 4, again using Pascal's triangle, 1, 4, 6, 4, 1. Whew. Minus x to the 4, things simplify. Factor out your h. H's cancel out, and we can evaluate our limit. And now we're going to want to, we've done 3. We're going to want to look at the pattern at the first one, the second one, and the third one. And then I want you to think, just by looking at them, if f of x was x to the 5, what do you think the derivative would be? All right, so the pattern we notice is the power becomes the coefficient, and then we subtract 1 from the power. And this is the power rule, which can be written this way. So here we have the power rule. If you have x to the n could come out in front as a coefficient, and you could subtract 1. And this works not only for whole numbers, but for any rational number. So even if you had x to the 2.3, you could bring the 2.3 out in front and subtract 1 from the exponent.